Vaccination Edward Jenner's smallpox vaccine. The story of vaccination begins with a simple observation: milkmaids who caught mild cowpox seemed immune to deadly smallpox. This insight led Edward Jenner to perform one of history's most daring medical experiments in 1796, changing medicine forever. Jenner took pus from a milkmaid's cowpox blister and scratched it into a young boy's arm. When later exposed to smallpox, the boy remained healthy. This groundbreaking discovery introduced the concept that a weaker version of a disease could train our bodies to fight the deadly version, like giving our immune system a practice run before the real battle. What made this discovery so revolutionary wasn't just the technique, but the entire concept of preventive medicine. For the first time in human history, we could stop diseases before they started, rather than just treating them after people got sick. This shifted the entire paradigm of medical thinking. The controversy was immediate and intense. Religious leaders claimed it was against God's will to inject animal material into humans. Some doctors refused to believe that something so simple could prevent such a deadly disease. Political cartoonists even drew people growing cow parts after vaccination. Despite the opposition, the results were undeniable. Vaccination spread across the world, eventually leading to smallpox's complete eradication in 1980, the first disease humans had ever completely eliminated. Today's vaccines use the same basic principle Jenner discovered, saving millions of lives every year. Germ theory of disease. Louis Pasteur. Before germ theory, people believed diseases were caused by bad air, divine punishment, or an imbalance in body fluids. Louis Pasteur's discovery that tiny organisms cause disease was like switching on a light in a dark room. Suddenly, everything made sense. Pasteur's work began with spoiled wine, of all things. While studying why wine went bad, he discovered that tiny microorganisms were responsible. This led him to a revolutionary thought: if microscopic life could spoil wine, could it also make people sick? This simple question would revolutionize medicine forever. Through careful experiments, Pasteur proved that diseases don't appear spontaneously but are caused by specific organisms. He showed that these germs could be killed by heat, now called pasteurization, and that preventing their spread could stop diseases. This was like giving doctors a new pair of glasses. Suddenly they could see the enemy they were fighting. But the medical establishment initially rejected his ideas fiercely. Many doctors were offended by the suggestion that they themselves might be spreading disease by not keeping things clean. The idea that invisible creatures could cause illness seemed like fantasy to many professionals. But Pasteur's most profound contribution wasn't just identifying germs, it was showing that diseases could be prevented by controlling these microscopic invaders. This led to revolutionary changes in hygiene, surgery, and public health that have saved countless lives.
Click subscribe to this channel to get more topics you love.
Hand washing in medical practice. Ignaz Semmelweis. Imagine a doctor going straight from dissecting a corpse to delivering a baby without washing hands. This was normal medical practice until Ignaz Semmelweis made a connection that seemed obvious in hindsight, but was revolutionary at the time. Working in a Vienna hospital in 1847, Semmelweis noticed that women giving birth in doctor-attended wards died far more often than those in midwife-attended wards. The key difference: doctors performed autopsies, while midwives didn't. He theorized that cadaverous particles on doctors' hands were causing deadly fevers. When he instituted mandatory hand washing with chlorinated lime solution, death rates plummeted from 10% to less than 1%. This dramatic improvement should have been celebrated as a breakthrough. Instead, Semmelweis faced ridicule and hostility from the medical community. The resistance was partly because his ideas challenged the existing medical beliefs, and partly because doctors were offended by the suggestion that they were causing deaths. The idea that invisible particles could transfer death from corpses to patients seemed absurd to many doctors. The tragedy of Semmelweis is that he died in an asylum, ridiculed and rejected, before his ideas were accepted. Today, hand hygiene is the cornerstone of medical practice, saving countless lives through such a simple act. His story reminds us that sometimes the most important truths are the hardest to accept. The blood circulation system. William Harvey. For centuries, people believed blood was created by the liver and consumed by organs like fuel. William Harvey's discovery that blood continuously circulates through the body was like discovering that the Earth orbits the Sun. It completely changed our understanding of how we function. Through careful observation and mathematical calculations, Harvey proved that the heart pumps blood through a closed system of vessels. He showed that valves in veins prevent blood from flowing backward, and that the same blood circulates repeatedly. This was revolutionary thinking in the 1600s. His most brilliant insight came from simple math. He calculated that the heart pumps more blood in an hour than the body could possibly produce in a day. This meant blood had to be reused circulating rather than being consumed. This logical deduction changed medicine forever. The opposition was fierce. Traditional doctors couldn't accept that the ancient Greek theories they'd built their careers on were wrong. Some patients even refused to be treated by doctors who believed in circulation, fearing this radical new idea would harm them. Harvey's discovery laid the foundation for understanding blood pressure, heart disease, and the entire cardiovascular system. It showed that medicine could advance through careful observation and logical reasoning rather than just accepting ancient wisdom. Anesthesia in surgery. Before anesthesia, surgery was a nightmare of screaming patients held down by strong assistants. The introduction of surgical anesthesia in the 1840s wasn't just a medical advance, it was a humanitarian revolution that changed the very nature of surgery. The first public demonstration of ether anesthesia by William Morton in 1846 was dubbed Ether Day when the patient awakened pain-free after surgery, declaring he'd felt nothing. It was like witnessing a miracle. For the first time, surgery could be performed without the patient experiencing torture. However, early anesthesia was dangerous and controversial. Some religious leaders argued that pain was God's will and shouldn't be prevented. Others worried that unconscious patients might be taken advantage of, or that the soul might leave the body during anesthesia. The pioneers of anesthesia faced numerous challenges, including deaths from overdose and professional ridicule. They had to discover safe dosages through trial and error, often experimenting on themselves. several early practitioners died from their self-experiments. Today, anesthesia is so refined that millions of surgeries are performed safely each year. This discovery transformed surgery from a last resort torture to a precise, humane medical practice. It's considered one of medicine's greatest gifts to humanity. In vitro fertilization (IVF), when Louise Brown, the first test tube baby, was born in 1978, it sparked a revolution in human reproduction. IVF showed that science could help create life where nature alone couldn't succeed, opening new possibilities and ethical debates that continue today. The breakthrough came from British scientists Robert Edwards and Patrick Steptoe, who succeeded after years of failed attempts. They discovered how to fertilize an egg outside the body and successfully implant it in the womb. This was like discovering how to create a miniature universe in a laboratory. Religious groups immediately opposed IVF, arguing that creating life in a lab was unnatural and that discarding unused embryos was unethical. Others worried about the psychological impact on children born through this method or feared it would lead to designer babies. Despite the controversy, IVF has given hope to millions of infertile couples. The technology has evolved to include genetic screening, which can prevent inherited diseases. This raises new ethical questions about how far we should go in controlling human reproduction. Today, over 8 million IVF babies have been born worldwide. The technique has expanded our understanding of human development and opened new frontiers in reproductive medicine. Stem cell research and therapy. Imagine cells that can transform into any type of cell in your body. That's the magic of stem cells. When scientists discovered they could harness these master cells in the 1980s, it opened a door to potentially treating previously incurable conditions. The most controversial breakthrough came when researchers found that embryonic stem cells had the greatest potential. These cells, derived from early-stage embryos, can develop into any type of body tissue. This sparked intense ethical debates about using embryonic tissue for research, even if it could save lives. A major turning point came with the discovery of induced pluripotent stem cells (iPSCs) in 2006. Scientists found they could reprogram adult cells back into a stem cell-like state, potentially bypassing the need for embryonic cells. This was like discovering how to turn back time at a cellular level. The potential applications are mind-boggling, regenerating damaged heart tissue after heart attacks, creating new insulin-producing cells for diabetics, or even growing replacement organs. Some experiments have already shown success in treating blindness and spinal cord injuries. However, challenges remain. Some treatments have caused tumors, and there are concerns about cells being rejected by the immune system. Despite these hurdles, stem cell research continues to push the boundaries of what's possible in medicine. DNA structure and genetic engineering. When Watson and Crick unveiled DNA's double helix structure in 1953, they didn't just discover a molecule, they found life's instruction manual. This breakthrough let us understand how genetic information is stored and passed down, opening the door to rewriting our genetic code. The ability to read and modify DNA has led to revolutionary treatments for genetic diseases. Scientists can now identify faulty genes, understand how they cause disease, and potentially fix them. It's like having a spell checker for our genetic code. able to find and correct mistakes. The controversy exploded with the development of genetic engineering tools like CRISPR, which can edit genes with unprecedented precision. This raised fears about designer babies and the ethical implications of altering human DNA. Could we create superhumans? Should we? The debate intensified when Chinese scientists announced the birth of gene-edited twins in 2018. This crossed a line many thought shouldn't be crossed, making genetic changes that could be passed to future generations. The scientific community largely condemned this as premature and unethical. Yet genetic engineering has already revolutionized medicine, agriculture, and biotechnology. It's given us new treatments for diseases, crops resistant to climate change, and insights into human evolution. The question isn't whether we'll use this technology, but how we'll use it responsibly. Organ transplantation. The first successful human organ transplant in 1954, a kidney transplant between identical twins, marked the beginning of a new era in medicine. The idea of taking an organ from one person and giving it to another seemed like science fiction, yet it became reality. The biggest challenge wasn't surgical technique, but rejection, the body's immune system attacking the transplanted organ. The discovery of immunosuppressive drugs in the 1960s was crucial, allowing transplants between non-related individuals. This was like finding the key to unlock compatibility between different bodies. Ethical controversies quickly arose around organ donation. Who should get priority for scarce organs? Is it ethical to pay donors? Should organs be taken from executed prisoners? The development of brain death criteria in 1968 raised new questions about when it's appropriate to harvest organs. Today we're pushing new boundaries with xenotransplantation and growing organs from stem cells. In 2022, the first pig-to-human heart transplant marked a potential solution to organ shortages. Yet each advance brings new ethical questions. The field continues to evolve with new technologies like machine perfusion to preserve organs longer and artificial organs. Each breakthrough brings us closer to solving the organ shortage crisis while raising new ethical considerations. Birth control pill. When the first birth control pill was approved in 1960, it wasn't just a medical breakthrough, it was a social revolution. For the first time in history, women had reliable control over their fertility, separating sex from procreation in a way that would transform society. The pill's development faced enormous opposition. In the 1950s, even research on contraception was illegal in many states. The scientists who developed it, including Margaret Sanger and Gregory Pincus, had to disguise their research as fertility studies. They were pioneering not just medicine, but social change. The controversy wasn't just religious or moral. Early versions of the pill had serious side effects due to high hormone doses. Some doctors worried about long-term health impacts, while others refused to prescribe it to unmarried women. Yet demand was so high that by 1962, over 1 million American women were taking it. The pill changed society profoundly. Women could reliably plan their families and careers. Population growth slowed in developed countries. Relationships changed as couples could choose when to have children. It was a medical discovery that became a catalyst for women's liberation. Today, newer versions with lower doses and fewer side effects are used by millions worldwide. Yet access remains controversial in many places, showing how medical discoveries can continue to intersect with social and religious values. Human genome mapping. The Human Genome Project, completed in 2003, gave us the first complete map of human DNA, all 3 billion letters of our genetic code. This was like getting the first complete atlas of what makes us human, showing not just where genes are, but how they work together. This massive undertaking revealed surprising findings. Humans have far fewer genes than expected, about 20,000 genes rather than the predicted 100,000. This showed that complexity comes not just from the number of genes, but how they interact. It's like discovering that a symphony comes from how notes work together, not just how many there are. The project raised major privacy concerns. Could genetic information be used for discrimination? Would insurance companies deny coverage based on genetic predisposition to diseases? These questions led to new laws protecting genetic privacy. Perhaps most profoundly, the Genome Project showed that all humans are 99.9% identical genetically. The differences we see in appearance and health come from tiny variations in our DNA. This scientific fact challenged many social prejudices about race and human differences. Today, personal genome sequencing is becoming affordable and common, raising new questions about how this information will affect medicine, privacy, and our understanding of ourselves. Antibiotics. Alexander Fleming's penicillin. Alexander Fleming's accidental discovery of penicillin in 1928, when he noticed that mold killed bacteria in a contaminated Petri dish, might be the luckiest accident in medical history. This observation led to medicines that would save millions of lives. The development of penicillin during World War II transformed medicine. Infections that were once deadly became easily treatable. Surgeries became much safer. It was like humanity finally found a weapon to fight back against its oldest microscopic enemies. However, the success of antibiotics led to overuse. Doctors prescribed them unnecessarily, and farmers used them routinely in livestock. This created the perfect conditions for bacteria to develop resistance, leading to today's crisis of antibiotic-resistant superbugs. Fleming himself warned about resistance in his 1945 Nobel Prize speech, showing remarkable foresight. He cautioned that misuse of penicillin would lead to bacteria learning to defend themselves. Today, this warning has become a major global health challenge. The race between new antibiotics and evolving bacteria continues, reminding us that even our greatest medical discoveries require careful stewardship to remain effective.